Here we are looking at some more exponent work. And this you'll see is expressions with rational exponents. Rational. What does the word rational mean to you? Notice we got the word ratio in there. And ratio can be written as a fraction. So it's exponents that take the form of fractions. They're fun. If I tell you that the square root of 25 has the same value as this expression, 25 to the 1/2 power, what does that tell you about what a 1/2 power means? If I tell you that the square root of 9 can be written as or equals 9 to the 1/2 power, similar thing. What does 1/2 power mean to you? What does an exponent of 1/2 mean? It means take the square root. It means take the square root of a number, doesn't it? Okay? When we write the square root symbol, there is an invisible 2 there. It's going to crop up when there are other roots, but for the square root, it's an invisible 2. So, notice the relationship between the 2 and where the 2 is here in the exponent. What about 8 to the 1/3 and 125 to the 1/3? What do you think that means? Using what we learned up here, maybe it means that the 1/3 root is, the 1/3 power, is the third root of a number. And that is what it means. Here, 125 to the 1/3 power means what is the third root of that number. So we can go through and we can actually put some number answers here, can't we? 25 to the 1/2 power. So I say to myself, okay, that's the same as 25, square root of 25, 5. And for the time being, we're just thinking about principal square roots, the positive version answer, okay? 9 to the 1/2 power, same as what square root of 9, 3. 8 to the 1/3 power, what is the cube root of 8? And that is 2. And lastly, what is the cube root of 125? 5. Now you don't have to write out this middle step, I'm just showing you what it is. So you can just go ahead next time, 25 to the 1/2 power, I know that means take square root, and I know the answer is 5. So if we look at the definition of b to the 1/n power, 1 over n, a fraction power, is the nth root of b. The n is just tucked inside the little kind of the elbow of our radicand here. It's not multiplying with it. It is a little symbol expressing what type of root we're taking. The nth root of b. And there are some qualifications for what b and n have to be. b is going to be a number greater than 1. This number here, this works when b is greater than 1. And n we use as an integer, and it's going to be greater than or equal to 2. 2, 3, 4, 5, 6. All of the integers 2 and greater. And b, the number here, what we're finding the root of, is going to be greater than 1. So those are the qualifications for us using this definition. If I see a fraction power, I know it's the nth root. Okay? And these are some nice examples. Board 2. Can we see that? Yep. We just got a reminder of what we had at the bottom of board 1. b to the 1/n power is the nth root of b, and there's another example. This is not 4 to the 2/4 power, this is board 2 of 4, just in case you're worried about that bit. So how about, this time, I'm telling you that 1,000 to the 2/3 power is equal to 100. What does that mean? I'm also telling you another example. It's not really an or, it's another example. 32 to the 2/5 power is 4. Another example. 81 to the 3/4 power is 27. maybe put me on pause. Have you figured it out yet? What does all of this mean? Where did those numbers come from? Let's look at this one. Of these examples, let's look at this one. If it had been just 32 to the 1/5 power, so back from the previous board, let's look up here. Okay, that means the 5th root of 32. And with any luck, you're going to recognize that that answer is 2. So then we've done like half of the problem. We've taken the 5th power, but look where the 2 is. It's in the numerator situation. And that for us is now going to mean take the power, take the second power. So I found the 5th root. So first of all, I found the 5th root of 32. And next, we actually have to take the second power of that answer. So what's in my parentheses equals 2, and 2 squared is equal to 4. That's where we got our answer from. Let's do this one, shall we? 81 to the 3/4 power. So we know that we need to take the 4th root, and I suggest we do that first. We'll take the 4th root. What is the 4th root of 81? 4th root of 81 is 3. We're halfway there. Then we do 3 to the 3rd power. That's where we get the 27 from. So we've broken it down into 2 sections. We'll take the root and then the power. By the way, we could take the power and then the root. But I don't know about you, but I can't easily, in my head, do 81 to the 3rd power and then take the 4th root. That is beyond my capabilities mentally. But I can easily take the 4th root and then the 3rd power. Let's look at this one. Why is it 100? We're taking the 3rd root of 1,000. In my head, I know that's 10. Then I'm doing 10 to the 2nd power, which is why it was 100. So that explains those examples. And our definition down here, the definition of b to the m over n, the m over n power, is, and we're going to write, there's going to be 2 ways of writing it. I'm going to write the first way that I use, and then I'm going to show you the second way that you can do. I always take the nth root first. After I have that answer, I will take the nth power. So the n represents what is the root. The m represents what is the power. Or we could write it as you could, if you wanted to, take the nth power first. Let's do b to the nth first. And then take the nth root. But if you think about the examples we've had up here, the numbers are going to get very large, unrecognizable, and I don't think we'd then be able to take the root easily without using a calculator. And that defeats the whole purpose of making something as simple as we can. So we know how to take the 1 over n power, and we know how to take an m over n power. And at the end there'll be some practice questions, but you'll have these notes in front of you. And they're kind of cute to do. Then, this is 3rd board of 4. Some interesting results from using this. Because if I ask you what is the cube root of x cubed, what is the cubed root of x cubed? What times itself 3 times will give us x cubed? Some of you in your head are saying, well, that's got to be x, isn't it? You're right, and I want to prove it using the definitions we just had. Because this says what times itself 3 times is x cubed, or x times x times x. Why? Remember, cube root can be written as to the power of 1/3. So I could rewrite this as x cubed to the 1/3 power. And do you recall our power of power property? That's when we multiply our exponents together, and 1/3 of 3 is 1, x to the first, and anything to the first power is itself. So we got the same answer both ways. Thinking and then applying a new definition that we just learned. And then using one of our properties we learned before. So we have to really wrap all of these things together, don't we? So the cube root of anything cubed will be that thing. So if you think about this one, remember there's an invisible 2 there. And you might have already said, well, the square root of y squared is y. Let's prove it. Square root can be written as to the power of 1/2. Power of power property, we're going to multiply these two together and get y to the first, and that can be written as y. So one could be tempted to say that this undoes that. Yeah, I think I would like us to be able to know by the use of properties that that's how we get it. But it does kind of undo it. We have to be careful though if we're ever talking about the positive and negative versions. So I think we'll just talk about using our properties to do this. So let's look at these. These are really nice, don't they? I could convert this to the power of 1/3. So I would have x to the 12th, y to the 6th, all to the 1/3 power. If I'm multiplying by 1/3, that is the same as dividing by 3. Multiply by 1/3 is the same as dividing by 3. 12 divided by 3, or 12/3, is 4. 6 times 1/3, or 6 divided by 3, is 2. Final answer, x to the 4th, y to the 2nd. For this one here. And notice, little shortcut, 12 divided by 3, 4. 6 divided by 3 is the 2. Why it works is because we can turn that root symbol into a power of a fraction. If we go over here, let's apply. Remember, this is now power of a power, also a power of a product we need to know. Apply to both parts, and we do that by multiplying because they're powers of powers. 2 times 1/2 is 1. X, I'm not going to write the invisible 1 now. 2 times 3 is 6. So our answer would be x, y to the 6th. X times y to the 6th. I'm going to just skirt down here. I'm going to apply my power of 8 to all of my factors of this product. 8 times 3 is 24. 8 times 1/4 is 2. 8 times 0 is 0. Anything to the 0 power is 1, so he disappears. Final answer, a to the 24th, b to the 2nd. And this one, we got some negative exponents going on too. We got some fraction exponents. We've got pretty much everything going on here. Apply to both factors using our power of a power property. 6/2 are 3. 6 times -1, -6. Rewrite it using positive exponents only. He's not being told to move. But this is the same, remember, as the reciprocal of the positive version. The positive version goes downstairs, under the fraction bar. And we have x to the 3rd over y to the 6th power. A lot to take in. Hopefully you've been writing notes. You pause me, you can rewind me, pause me, fast forward me. As long as we've got these examples down. The last board, 4th of 4, is a summary of what you need to do if you're asked to simplify expressions and they're involving exponents. This is what you have to be on the lookout for. So we get a different colour marker. For a simplified expression, The same base does not appear twice. So what properties would we use so that the same base doesn't appear twice? I would use, whoops-a-daisy, I would use a to the m times a to the nth is a to the m plus n. Remember that property? So that means we'll only have the base appearing once because we'll add the exponents. And the other one related to that is quotients, remember? A to the m over a to the n is a to the m minus n. So we got product of powers and quotient of powers. That handles so the same base does not appear twice. To handle no powers of powers, we'll use our a to the m to the nth property, and that will be a to the m n. How will we make sure that no products or quotients are raised to powers? We'll use our powers of products and quotients rules. That is the ab to the m is am b to the mth, a to the mth, b to the mth. And the related one is this one. You have these in your notes from regular 8th grade classrooms, so this shouldn't be, you should have all of these. You might want to jot them down. It's really telling us, remember to use all your rules. All coefficients are relatively prime. We haven't really talked about that. But I want you to pretend, let's say we've, simplified, and we get to something like this. 6a over 9b, let us pretend. Imagine this is just a fraction. Well, it is a fraction, but imagine that I asked you to put it in simplest form. Wouldn't you divide 3 out of top and bottom and get 2 and 3? Final answer is 2a over 3b. And then no number can divide both into the 2 and the 3. It means they're relatively prime. Not prime, but relatively prime to each other. We also have to be on the lookout. If we are simplifying completely, we're not going to have any negative exponents. We'll rewrite them. Remember, our definition for this was a to the negative n is 1 over a to the positive n. That was the definition of a negative exponent. Also what we know that anything to the 0 power is 1. We just learned that b to the 1/nth power is the nth root of b, and to the m-nth power is, I'm going to write the version that I prefer, take the nth root first, and then the mth power. Wow. This is everything we now know on exponents. And this all has to be done for us to completely say that an expression has been simplified. So I'll be handing out a practice sheet and we'll have lots of practice on these. And that's about it. Thanks very much.